Hello guys, welcome back to my channel. This session is session 12 of deep learning for teens. In this session, I'm gonna talk about quantization in deep learning, and the reason that we will do that, and all different types of quantization. And we first go through the theory, and then we're gonna have coding part. And by the way, I'm gonna share all the code with you and the data set that I use in this presentation. And finally, I'm gonna have an interesting assignment for you guys. Okay, so first of all, let's talk about quantization and why we need quantization. So assume something like this. When we have edge devices, something like microcontroller, Raspberry Pi, and other stuff, so we don't have too much space for big models, so we need to change it somehow to a smaller models. Okay, and this is the reason that we're gonna use quantization. So quantization help us to convert big models to a smaller one. Okay, so as I told you, we have two types of actually quantization. We have post-training quantization and quantization aware training. So first of all, let's talk about post-training quantization. So in post-training quantization, we use TFLite to convert the model to this a smaller model. Okay, and this way is really quick, a really quick approach, but the problem is we're gonna lose the accuracy, and that's not good at all. So this is the reason that we're gonna use quantization aware training. So in quantization aware training, so we're gonna get the model, we apply a quantize function, and then we're gonna do something like training, actually transfer learning, and then we're gonna get the tune quantize model, and finally, as a last step, we're gonna use tf.lite to make it understandable for edge devices. Okay, let's get it started. So for this one, actually, so for this one, I actually execute the code before this presentation, and I just import some libraries, and then today I'm using Fashion MNIST dataset, and I'm gonna share this dataset with you guys. You don't need to be worried about that. And after loading this data, so I'm gonna just divide it by 20 250 55, sorry. So the reason is I want to just normalize it somehow. So I visualize one of the data to see what we have actually, and then I'm gonna build a model, and we have a flattened layer, we have two dense layer after that. Okay, and ReLU and softmax for activation function. We already cover all of these topics, so if you don't know or you need to remember something, I really highly recommend you to watch my previous video. So after that compile, and then we have the model. I just use one epoch to make it actually faster. Okay, but usually we use more than one, and evaluate it on X train. And the reason is I want to see if we face overfitting or not. So you can see the accuracy here is 84 and here is 85. Okay, and I save the model. So, and here for post-training quantization, I just load the model that I used, and here I just use a TFLite converter, as I told you, to make it understandable for this kind of edge devices. And finally, I save the model, and this is without, actually this is without quantization. And I'm gonna do the similar stuff, but this time I'm gonna say I want to use actually quantization. So again, I load the model, and again, same thing, but here I use the quantization. Okay, and I just save both of them to make sure to just understand it and compare them. Okay, so and here I just got the ln of both of them. So, and if you see, this is the original one. The original one is, the size is uh, around four 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 for around 400,000, and for this one is something like 100,000. Okay, this is much really less than this one. Okay, and but the problem is here we lost the accuracy somehow, and that's not good at all. So this is the reason we're gonna use quantization aware training. Okay, so like the previous one, we made a model like here. So this is the exact same model, and we compile it, we fit it, and here I just load the model that we built and compile it, and then model.summary.c all the layers that we have, and after that uh, I fit it with X-terrain and Y-terrain, and again one epoch, and here I just evaluate it, and here this is the point. So I try to use the quantization here. I try to use the quantization here, and I just use the quantization, and finally I have the model. And if you see, the size of this model is half of the original model, but the good thing is we're not gonna lose the accuracy. Okay, okay, that's it for this part, and just let's back to presentation. I have one more thing for you guys. So assignment, I want you guys use MNIST dataset and repeat the same steps that I have done in my presentation. Okay guys, thank you so much, and see you in next video. Bye.